So, welcome everyone to our 13th lecture from our lecture series on network inequality. My name is Samuel Martin Gutierrez. I'm a postdoc here at the Complexity Science Hub in the Network Inequality Group. And today we welcome Indira Sen. She's a postdoctoral researcher at the Political Science and Public Policy Department at the University of Constance. And she researches on understanding and characterizing the measurement quality of social science constructs like political aptitudes and abusive content from digital traces, combining natural language processing and social science measurement theory. In the past, she was a doctoral student at RWTH Aachen and Gessis Leibniz Institute for Social Science, working in computational social science. She has done internships at Snap and Nokia Bell Labs. And Indira, whenever you want, please go ahead. The stage is yours.
Awesome. Thank you so much, Samuel, for the introduction and the rest of the team for inviting me. I'm very excited to be the 13th lecturer. That's a lucky number, I suppose, especially if you're Taylor Swift, but hopefully this will be interesting. Okay, you might see that the title is slightly different, especially those who might have come from Twitter, but that's only because I wanted to de-emphasize a few parts and maybe zoom out and just generally talk about measurement and representation biases in LLMs when using them for simulations, and not just focus on the multilingual and multicultural aspects, but those will come in as well. So I promise that was not clickbait. Okay, let's see if I can go forward. Yes, good. So you already gave a great introduction, so I can just skip this and get into it. Okay, so this is a bit of a rewind because I want to talk about the research that I did during my PhD and how that informs some of the work that I just mentioned. So it might seem very different, but again, bear with me, there is some connection. So the question that I was interested in during my PhD was that how can we use digital trace data to measure social phenomenon better? And maybe just as a bit of brief background, I'm sure many of you know, when social scientists measure social phenomenon, they typically rely on more traditional sources of data, such as survey data or observational data. But ever since we had the internet and especially social media and web platforms, this was a very rich source of data that also encoded people's behaviors. And many researchers realized that they could use this data also to measure social phenomenon. So it was a natural complement to the more traditional sources of data. However, while this data has several potentials, the fact that it's a lot more voluminous than traditional sources of data, it also has less lag when we think about acute events like crisis events. There are also several problems with it. One example could be that if we think about Twitter data, not everybody is on Twitter. Moreover, it's not even a random sample that's on Twitter. There are some self-selection biases about who prefers to be active on Twitter. So these are what are called as errors. And when you have systematic errors, like, for example, more extroverted people posting more on Twitter and their data being recorded in these data sources, that's a systematic error, or what we call a bias. And when it comes to traditional sources of data like surveys, social scientists thought a lot about this type of errors simply because it's been around for a long time, and they looked into statistics and measurement theory to try and come up with how to address these types of errors, right? So when we have surveys, which can also be non-representative, we have techniques of trying to address these systematic biases by reweighting our sample by giving more emphasis to certain demographics than others simply because they might be underrepresented in our sample. So traditional social scientists had thought quite a lot about these different error sources, and they tried to make their measurements from these traditional techniques much better. However, given that digital traces were much more recent, we've not had that same benefit over here. So one way that we tried, or in my research, we tried to address these errors in general was to come up with an error framework. Error frameworks were quite well established for survey methodologists, where this is an example of the total survey error framework, where they would say that they want to measure a particular social phenomenon or construct in a particular target population and go all the way down to the survey statistic. And they would think about different errors in each of these steps, like non-response error, the fact that some survey respondents are less likely to reply to a particular survey. And they thought about these errors in a systematic way so that other researchers who are using surveys can also do the same and reflect on the different issues that might be there in their surveys and how they could potentially address that. And if not address that, at least document that as thoroughly as possible so that they can give some uncertainty estimates for their measurements, right? So the idea was to see if we could create a similar error framework for digital trace data. And this is the visual representation of the error framework that we came up with for digital trace data of human behavior from online platforms. Here, just like the total survey error framework, which has a measurement branch and a representation branch, we also tried to do that. And the reason behind this is that these are two distinct sources of errors. Measurement errors occur when we just want to measure one particular social phenomenon or the construct, even in one person. We don't even have to think about many people and if they are representative or not, but just one person. And let's say I'm surveying them. Are they being truthful? Like, are they actually giving me honest responses or not? So that would be a measurement error. And on the other hand, we have representation errors or errors due to how my target population is defined and if my sample actually covers that target population or not. So here, the example that I said about Twitter having only extroverted people, or let's say only being popular amongst younger people, might affect my representation, right? Because I'm not being able to capture the opinions of an older demographic. So that's why it's quite useful to conceptually differentiate between these two errors, and that's what we did. And we came up with new errors that are particularly pertinent when we think about digital traces. So for example, the effect of the platform, right? Like, for example, how recommendation systems might push people to behave in certain ways. I'm sure this is something that many of you in the network inequality team work on about filter bubbles and echo chambers and how that might be affected by the platform's recommendation or ranking characteristics, right? So these are unique errors that survey methodologists did not care so much about, but are quite relevant when we think about digital trace data. So yeah, this is what I just mentioned, measurement errors due to how the construct is defined and operationalized, and representation errors due to who is being measured. So this was my PhD research, which has nothing to do more or less with this talk. So why did I bring it up? The question is, what do digital trace data and large language models have in common? One thing that is quite popular nowadays is a third form of data to measure such social phenomenon, and that is via large language models. And we'll get into this in a bit. So it could be either using large language models to simulate real people, use large language models to analyze content, and so on. So in some ways, you can think about these three eras of data sources, with the first one being about survey data, the second one about digital traces, and the third one, LLMs, right? Now, LLMs can be used to measure social phenomenon as well. And what is the connection with digital trace data? LLMs are trained on a lot of digital trace data. Like definitely there's Wikipedia data in there, which forms a large chunk of its training data, but also data from social media platforms. And this was particularly evident when sometime back Reddit, or rather Gemini, came out. And this is a screenshot from Gemini, and where somebody was asking, how can I get the cheese to stick to my pizza? And Gemini gave an answer that was somewhat questionable, which was suggesting to use non-toxic glue to make the cheese stick. And it turns out somebody said almost the exact same thing on a subreddit called Shitty Life Pro Tips. So 1/8 cup of Elmer's non-toxic glue can do the same thing. So you can basically see that a lot of the digital traces that come on these platforms like Reddit, sometimes questionable, sometimes much more accurate, are in the training data of these LLMs, even though it's not super clear, also because these LLMs are quite big and it's hard to always audit them clearly. But still, definitely there's a lot of digital traces in their training data. And all of these issues that we saw in digital traces, like these representation problems and these measurement problems, they now also trickle into LLMs, right? And they take new forms, and that might trickle into the simulations that we make or when we use LLMs for content analysis. So yeah, LLMs can be used as proxies of people for simulations of content analysis, and these biases that come in digital trace data can also be relevant in these simulations as well. And again, I'm sure many of you are familiar with this, but just to set the context a bit better, these are some examples of LLM simulations that I'm talking about. These papers are now already ancient in machine learning paradigm, because they're from like 2023. But these were some of the first papers that came out using large language models and simulations. And so this one was trying to replicate human subject studies, such as the Milgram shock experiment or the wisdom of the crowds, using large language models, finding quite some success when using ChatGPT and GPT-4. Another one, which is a bit different, but also uses large language models, but this time to simulate survey respondents, particularly in the US setting, where they basically say that the bias that's there in this data can actually be useful. They call it a form of algorithmic fidelity, where they say that because LLMs are trained on biased data, they also capture these biases. So that means that when I ask an LLM simulation to answer questions, they would actually be realistic, right? So, and they found this to be the case for American politics, at least. So in that sense, LLMs can be used as a good substitute for real survey participants if we want to get some public opinion. That was one of the potential use cases according to this paper. And then finally, this one is another example which also kickstarted off a lot of excitement. This was about generative agents using LLMs and how you could use large language models to create personas of people and then just leave them alone in an environment. And then you could basically see a lot of what they call emergent properties, where these LLM agents would plan by themselves, where they would communicate on their own. And then you could study things like information diffusion and social norms developing, which was super interesting. These are things that are quite hard to study via traditional survey data. And so in that sense, LLMs seem to have quite a bit of potential to finally learn about some of these specific phenomenon that we didn't quite know much about. So this is now a bit of a rough mapping of the different ways that LLMs can be used as proxies of people. We already talked a bit about simulating people, where you could simulate individuals, you could also simulate groups of people. But that's not just the only way LLMs serve as proxies of people. There are also other important aspects where they've been used. So one big one is content analysis and content generation. So for example, labeling content, which is quite something that's useful when we think about research with digital trace data, right? Where you have a lot of content, it's very difficult for people to manually label everything. So that's why we often relied on automated classifiers. And these LLMs seem to have like really high capabilities when it comes to this type of task, at least for certain types of labeling tasks. So that's one natural use case for them as well. And quite related to that, you could also use LLMs to generate further training data for other language models or other NLP or other machine learning models, not just text, but also for images or videos and so on. On the other hand, they can also be used for like assistive tasks. So creative writing is a big one where people can use LLMs to help them when it comes to writing novels, screenplays, so on. A lot of LLMs have also been used for advice. There was one specific controversy when a mental health helpline fired a bunch of its volunteer workers to replace them with LLM agents, only to find that the LLM agent was giving a lot of dangerous advice. But it seems that this is also a use case that LLMs can substitute people in, or at least complement people in. Depends, of course, the exact type of scenario, context, how accurate the model is, and so on. But this would be one other use case. And another one that's also related to platform or content analysis is platform governance. So you can use LLMs as recommendation systems. A lot of the recommender systems that we currently have are, of course, powered by automated models already. But LLMs are in that case quite multi-purpose because they can do many things at the same time, not just having a single model for one thing. So for example, you need a single model right now to rank posts. You need a single model to say if a post is toxic or not, and so on. To do many different tasks, you could have a single LLM do that. And that also relates to content moderation. So whether something should be deleted or not, whether a person should be banned or not. So these are again some use cases where LLMs are already being deployed, or at least people are thinking very much if LLMs would be suitable or not. And of course, this is not comprehensive. It could be that there are some other scenarios as well. But here I was specifically interested in how LLMs serve as proxies of people. And yeah, maybe in the Q&A, we can chat about other use cases as well. Yeah, so these are the connections, of course, when we think about content analysis and content moderation. And this part of the mapping can be the place where LLMs are used to measure social phenomenon. But when we think about LLM biases, this part is also very important, right? Because if now I have a biased LLM that seems to, for whatever reason, have a preference towards a particular demographic, and you deploy that for content moderation, then that's going to lead to demographic biases on the platform, right? So one example that we talk about here is political bias. And this was, again, something that many people talked about at the very beginning, where they would say that ChatGPT has a liberal bias. It seems to prefer liberal people and penalize conservative people. Now, the thing about this is that this type of political bias affects pretty much all of these different use cases, right? Like if I'm simulating people and my LLM has a liberal bias, that probably means that it's either being quite harsh towards conservative people, or it's just not modeling them very well, and it's not modeling conservative people accurately. If I'm thinking about content analysis, it could be that it doesn't understand the language of conservatives very well, which means that it has a tendency to make a lot of mistakes when analyzing the content of conservatives. If we think about assistive tasks for creative writing, for example, it might not, again, provide realistic backgrounds about conservative people, or always make it seem that conservative people are villains in novels or screenplays. And with platform governance, I already said this is also a big issue now, where many people seem to think that many of these social media platforms also have a liberal bias. One of the reasons apparently why Elon Musk bought Twitter. So yeah, if that's something that's there in the LLMs, that would also trickle down in the recommendation systems, where we would most likely see the content of conservatives being downvoted or downranked or not as visible, right? Again, I'm not saying that these things happen. That's something that people are still researching, because also how political bias is defined is a question that's not very clear, especially when we think about scenarios and context beyond the US context. But this was just to give an example about how some of these biases that come from the training data would affect pretty much many different ways when we use LLMs as proxies of people. Okay, so that's why we thought that maybe we apply a similar lens as we did for the error framework to LLMs proxies of people. So we can think about measurement issues and representation issues. Measurement issues, again, are something that where we don't talk about which people we are representing, but simply because, or simply how we are coming up with the measurement, right? And here I have some examples. So guardrails are a big issue when we think about large language models, especially when we are using LLMs to generate specific types of content. Like, for example, if I'm asking the LLM to generate training data, or asking the LLMs for creative writing, if it has guardrails and it does not want to comply with certain requests simply because it's dangerous, then that's not very useful for me if I want to write a realistic story, right? So this is a type of measurement issue. The other one is prompt brittleness, the fact that there's quite a bit of variance in these LLMs. Like you can give the same prompt 2 weeks down the line and get very different results, even if you keep all the technical parameters like temperature and so on the same. This is also because this is especially problematic for some of these commercial models, where we don't really know what ingredients are going into creating these models. This one, not as performant as state of the art. That's something that we'll get into in a bit in more detail. But the last one that I want to talk about as an example of a measurement issue is that many of these LLMs show non-human-like response biases. So these two papers particularly looked into survey responses and how LLMs respond to survey questions. And they basically found that very subtle variances that make people behave differently, for example, using negation, or very subtle rewordings that should not lead to big changes. And humans do fall victim to those sometimes. LLMs also fall victim to them, but in a totally different way. So they are not like humans when it comes to these response biases. So in that sense, it seems that cognitively LLMs behave differently, and that might have some implications of when I'm using LLMs to simulate survey respondents, right? Okay, so let's talk about this thing, not performant as state of the art. What do I mean by that? And here we'll talk about two specific scenarios. One is for generating training data using large language models, again, something that we often ask people to do, and labeling content. So how do LLMs compare to people as well as other automated models when it comes to some of these things? And here the background is that a lot of NLP models, like even before large language models like ChatGPT, were being used for social measurement, right? So these are tools that can be used for platform governance, for detecting hateful or offensive content. They were a lot more primitive than LLMs, but still quite useful. But as it turns out, when you have these NLP models that are supervised, they often have a tendency to learn dataset artifacts rather than the construct that they're supposed to model. So as an example, a sentiment classifier that has been trained on movie reviews would consider words like script and romantic to be indicative of sentiment, simply because of how these words are distributed in the training data, that they happen to be in one category more than the other. And the NLP model captures some of these spurious artifacts. And that means when I now use this model to detect sentiment in political speeches, it's not as good anymore because it doesn't see some of these dataset artifacts no longer. And that means that this model is not as performant. So these dataset artifacts are quite problematic, and we would like to try and reduce their effect on the model. And one particular solution to that is data augmentation and something called counterfactually augmented data. So counterfactually augmented data is obtained by making minimal changes to existing data points in order to flip their labels while still keeping the new data meaningful. So here, let's say I have an original sentence which says that they don't want a female commentator on a soccer match. That can be changed into a non-sexist sentence by making just two token level changes. So I change a female to an AI, and now I have a sentence that's no longer sexist. And here the idea is that I obtain a pair of data points which have opposite labels, but so these two have opposite labels. This is sexist, this is not. But they have everything in common except the construct. So we are saying that the sexism basically lies in these tokens. And now that I've removed that in the counterfactually augmented data point, I have like two pairs of data points which are very closely related to each other. And now if I train a model on these pairs, the classifier is going to focus on the source of sexism rather than artifacts like soccer or commentator and so on. So that was the hypothesis, and previous work using manually obtained data, like this manually obtained counterfactually augmented data, showed that this was indeed the case for several different types of classifiers like sexism classification or sentiment classification. That indeed, by training on this type of data, you get a more robust model. However, one issue was that all of these counterfactually augmented data were created manually, and that can be expensive and time consuming, right? So now the question is, can we use these large language models to generate these counterfactually augmented data automatically? So instead of having people doing it, let's ask the LLM to do it. So that's what we tried to do for these two tasks, sexism and hate speech. This is not the LLM data, but this is the data that's used for training models as well as for testing models. So we have in-domain data sets and out-of-domain data sets. Out-of-domain data sets basically allow us to measure out-of-domain generalizability or robustness. And then the NLP methods that we use are slightly more old-fashioned, let's say, methods such as a fine-tuned Roberta classifier. So this is not a generative model. like ChatGPT, but it can still be used for classification, and it's also thought of as a large language model, just not with generative capabilities. And now finally the part which is where we get the counterfactuals, right? So I already told you that we had the manual ones from previous work. We also have two other methods. One is called, or three other methods. One is Polyjuice, which uses a generative model, GPT-2. ChatGPT, so this was still the GPT 3.5 model, like the one that kind of came out in November 2022 and caused a lot of stir. And then Flanty-5, which is also a generative model, a smaller model compared to ChatGPT, but one that is from Google. So we basically use these models to create counterfactually augmented data. And now I'll just show you the results for hate speech, just because, so as to not take up too much time. But the results were basically similar for sexism as well. And the experimental setup consisted of these non-counterfactual models, so models that are not trained on any counterfactually augmented data, and counterfactual models that are trained on different types of counterfactually augmented data, so different models for different sources. And then we measure the results using macro F1. And so now I'll show you the results. Basically, here we have macro F1, and on the x-axis, we have the different test sets, right? So in domain, again, that's the one that has these spurious data artifacts, and the various out-of-domain data sets, which don't have spurious artifacts, right? And then you have all of these different classifiers. And this last panel basically averages the final out-of-domain performance. So let's see. So now we have the performance of the classifier, which is not trained on any augmented data. So just basically regular training data. And we see that it has high performance in domain and low performance out of domain. And the reason for this is that in domain is the one which has these data set artifacts, right? And these data set artifacts are no longer there out of domain. And so you can see that the model's performance falls because it can no longer rely on these artifacts. So that's not very good. That basically means that I don't have a very generalizable classifier. Now let's look at the classifier that's been trained on the manually augmented data. So in domain, its performance is lower than the one that's not trained on any counterfactually augmented data. But out of domain, on pretty much every out of domain data set, and then you can see this in the average one, that its performance is higher. So this basically means that I have a trade-off, that I'm trading off some performance in domain to have a higher performance out of domain. And this is because out of domain, again, it's a more challenging data set. It doesn't have these data set artifacts, but this model performing better basically tells me that it's not relying on these data set artifacts, and it's actually learning hate speech. So it's a more generalizable model. Now let's see how this performs when we compare it to ChatGPT counterfactuals. So that's this green triangle, and it's somewhere in between. So it's not as good as the manual counterfactuals, but it's still better than no counterfactuals, right? So in that sense, that's what I meant as not as performant as state of the art. So it's still not as good as the manual ones, but it's still better than nothing, right? And then when we look at the performance of the other classifier or the other counterfactually augmented data, they are not good at all. So that also shows you basically that ChatGPT is a very sophisticated generative model. And in fact, maybe if we tried this now with GPT-4, it could be that it already matches the human performance as well. Yes. And so on the other hand, why go into all of this training a Roberta model? Why not use the LLM to directly label the hate speech? And that's this black or gray star, where we just use ChatGPT for few shot labeling. And here we see that there's a bit of variance. Like it's quite good for certain data sets like OD5, but not so good for some others like OD1. So again, it's not as good as the state-of-the-art Roberta model. So you still get some benefit from training your own model. And this is something that other researchers also showed. For example, Caleb Sims basically showed this for a host of different social phenomenon, such as misinformation and stance detection, humor detection, that basically you still get some benefit from training your own model compared to using these models directly. So those were some of these representation or measurement issues about not being as performant as other state-of-the-art classifiers. The other use case where this multilingual aspect came into play was when we were trying to simulate groups of people. And here, the question that we were interested in asking and answering was, how well do LLMs mimic people's opinions on moral issues? And the test case that we use for this is this subreddit. Maybe some of you are familiar with it. It was very popular at one point of time. It's called Am I the Asshole, which is a subreddit where you can go and say that I did something that is maybe morally problematic. For example, this is one of these scenarios, and I had some conflict with people in my life. Now, am I the asshole or are the other parties the asshole? And so basically this entire community judges who was in the wrong in this moral scenario. And so in that sense, it's kind of a realistic case of moral dilemmas instead of like highly stylized problems like the trolley problem, but it's a more realistic manner of getting these moral dilemmas. And the community can basically label the asker as an asshole or not an asshole. So this is not the asshole where the other party is the asshole, or no assholes here. And so we basically collected some of this data, and this is the distribution of the community verdicts, where a majority of people, or where for a majority of posts, people say that there is no asshole over here. But for some, the next case is asshole. And then there's everyone sucks, which is basically all parties are terrible people. And so basically what we wanted to do was try and see if the LLM can also recreate this majority verdict or not. And so we gave ChatGPT the scenario and gave it the prompt and asked it to come up with one of these 5 or one of these 4 categories. And so we basically asked it to do this 5 times. And this no agreement case was if we did not have at least a majority agreement in 5 of these cases, right? So if you had 2 cases, which was asshole, 2 cases, everyone sucks, and 1 not the asshole. So that's a split vote, so we don't consider that. And otherwise, these are majority votes from the 5 labels from ChatGPT. And in a very quick nutshell, what we find is that this particular graph is what's interesting, where we see that the yellow bars are from Reddit and the blue ones are from ChatGPT, that ChatGPT just has a tendency to say not the asshole much more often. Or sorry, it basically says that the person is not the asshole. So it doesn't go with the asshole rating as much. It has a higher tendency to go with the everyone sucks rating. And so we were wondering, why does this happen? This is a bit funny, that why does the LLM seem to disagree so much with the Reddit opinion? And so one reason we think that this could be happening is because of acquiescence bias or sycophancy towards the asker. So this is something that other researchers have studied, this sycophancy bias, where the LLM has this tendency to align their answer to the perceived user view at the cost of accuracy when such views are not objectively correct, right? So maybe this is also something that you've experienced when chatting with ChatGPT, which is that it just wants to please you as the asker. And this could be something that's there because of the alignment process, because you want the person to be spending more time with the LLM or engaging more with the LLM. So if you have disagreements with that person, maybe that drives them away. And so this is probably a problematic aspect that also seeps into simulations, which is that maybe these LLMs are not very good at simulating disagreeable people or toxic people, right? Simply because of this acquisition sycophancy issue. And then when we try to do this in other languages, we automatically translate the post to Spanish and German. And then to make sure that the automatic translation was actually correct, we didn't use an LLM for this, by the way. It was just the Google Translate API. We also manually vetted some 10% of the translations. And we, again, asked ChatGPT to answer, but in that language, right? And we find that the performance or the behavior is different now in different languages. And we see for at least 32% of the cases for Spanish, the behavior changes. And also for German, but to a lesser extent. But again, like 1/4 of the content or 1/4 of the verdicts are now different for German. And this acquiescence bias or the sycophancy effect seems to be less in non-English. So here the LLM is no longer going with this everyone sucks verdict, but it has a higher tendency to now say asshole. So it's also maybe a curious thing, which is this alignment process might not be consistent across different languages. So also this multilinguality aspect, therefore, is quite important, and simulations in other languages are something that we need to look into. Okay, so I had another case study, but perhaps that's going a little too deep into it, and so I won't. Maybe I'll just talk a bit about representation biases, which are, when it comes to people, it's not really clear which people are well represented. So this algorithmic fidelity aspect, it's not clear which people are actually accurately and realistically mimicked versus caricaturized, like their differences are exaggerated. And so this is a study that we tried to do in the context of labeling. I'm not sure if Cheyenne is there or not in the audience, but I know he's interning at CSH. So maybe you can ask him. He's the one who led the study about annotator backgrounds and LLMs as annotators. So yes, please ask him about this. And so I'll move to the very end, which is that it's important to validate LLMs as proxies of people, because LLMs can revolutionize social science research, especially when we think of using them for simulations, such as in your networks. I know I didn't talk about networks at all, but that's where the connection is. But we need basically holistic and multifaceted benchmarks, right? That we need to measure political bias through many different facets and taking into account how these LLMs are actually used. So, because nobody is actually asking them some of these highly stylized survey questions unless you want to simulate survey respondents. But it could be that people are asking them for voting advice. So we need to make sure that our benchmarks reflect these multi-purpose use. And we have a lot of like bridges that can be built with traditional social science research, so particularly survey inventories or behavioral tests. And those are things that we can apply on LLMs to see if LLMs behave in a certain way, but keeping in mind that LLMs and humans seem to display very different biases. And so making or taking that into account when we develop our assessment tools. So for example, this is one example where if you ask the LLM a survey question, it gives a certain type of response. But if you ask a scenario-like question for the same moral issue, it gives a very different response. So this is basically the idea that you can see the LLM behaving differently when you're asking the same thing, but in different vehicles. So yeah, and then I'd like to end by thanking all of my amazing collaborators and also all of you for listening. And I'm very happy to take some questions or chat further.
Thank you so much, Indira.